Hi, welcome to Advanced Physical Science. This is 3.4b on linear collisions. Let's look at several examples. Number 1, Green Giant, 7,200 kilograms, is driving at 4.5 meters per second to the east, and the 150 kilogram Red Rover is driving at 5.5 meters per second to the west. They collide and stick together. So what type of collision is this? This would be an inelastic because they stick together. What is the momentum of the system before the collision? So the momentum of the system can be found by finding the momentum of each object. 7,200 times 4.5 plus 1,500 times a negative 5.5. Red Rover is going in a negative direction, should equal the 8,700 V. So grabbing your calculator, 7,200 times 4.5 plus 1,500 times negative 5.5 gives you a momentum of 24,150 kilogram meters per second. So therefore, part C says, what is the momentum of the system after the collision? That's the same thing. The law of conservation of momentum must be conserved. Finding the velocity, we simply take the momentum divided by the mass in order to get the velocity. So the combined momentum is 24,150 divided by 8,700. Again, grabbing your calculator, we get a velocity of 2.776 meters per second. Let's look at another example. Number 2, Bart is learning to skateboard. Bart is 45 kilograms and the skateboard is 12 kilograms. If Bart jumps off because he's scared at 3 meters per second, what happens? Well, what kind of collision is this? This would be an explosion because they started out together and ended up separately. The momentum of the system before the collision is 0 kilogram meters per second because nobody is moving. What is the momentum, therefore, after the system? Again, is 0 kilogram meters per second. Law of conservation of momentum says that the momentum before has to equal the momentum after. And finally, we have to find what the skateboard is. Writing our algebra equation of 57 times 0 has to equal 12V plus 45 times 3. And solving that equation, we get the skateboard goes backwards at a negative 11.25 meters per second. Finally, let's look at number 3. Number 3 says a 17 kilogram red ball moving north at 15 meters per second strikes a 12 kilogram blue ball moving south at 8 meters per second. When they collide, the 17 kilogram ball continues to move north at 6 meters per second. What happens to the blue ball? Well, this is an elastic collision because you have 2 objects before and 2 objects after. The momentum can be found where you have all of your information, which is on the before side. So that will be 17 times 15 plus 12 times a negative 8 as the momentum of the system, which would then be 159 kilogram meters per second. Therefore, the momentum of the system after the collision is 159 kilogram meters per second. Now, this asks a further question. What is the change in momentum of the red ball? Remember that change in momentum is equal to mass times the change in velocity. So the change in momentum is equal to the mass of the red ball, which is 17, times its change in velocity. Well, it went from 15 meters per second to 6 meters per second. That is a change of 9 meters per second. 17 times 9 is 153 kilogram meters per second. And then finally, we have to figure out the velocity of the blue ball. Well, we've got to go back up to our situation and realize that we have the momentum before, 17 times 15 plus 12 times that -8 should equal 17 times 6 plus 12 times something we don't know. And solving that equation, we get 159 is equal to 102 plus 12v. Subtract and divide. We should get a velocity of the blue ball to be 4.75 meters per second. Hope these help in your assignment today. Thanks for watching.